Hey guys, okay, so here is the beginning of the 5.2 end behavior. This is split into two videos just to make sure I can make the 15 minutes. And just starting out with this joke, so if you want to pause it for a minute and see if you can figure it out, answer will be revealed at the end. So before we can really graph polynomial functions, we need to know what they are, and we need to be able to manipulate them. So the first half is going to be on just some definitions and some evaluating, which means plugging in an x, getting a y. So a couple terms you need to know. Monomial. Monomial is a number or a variable or a product of them. So for example, 5 is a monomial, x is a monomial, but I could put a whole bunch together and that is a monomial. Polynomial is a monomial or sum of monomials. So if I put 5 and x and 5x squared y squared z squared together, that would be a polynomial. So polynomials, depending on the degree, have different names. And we'll talk about degrees. You talked about them in Algebra 1 a little, but we'll go into them a little bit more now. If I have a degree 0, it is a constant. An example would be y equals 4. Degrees are based on the number of variables that you have. I have no variables here, so my degree would be 0. 1 is called linear, and that's typical of what you've seen, y equals 2x minus 7. Notice that the exponent on that x is a 1, that's why it's degree 1. 2 would be, yep, you got it, just finished that unit, quadratic. An example of that would be x squared plus 2x minus 5. Notice my largest degree here is a 2. That's degree 2, quadratic. Degree 3 is called a cubic, which it would be a y equals x cubed function. Degree 4 is called a quartic, which would be a y equals x to the 4th. Degree 5 is called a quintic, and that would be x to the 5th. And that's pretty much as high as you guys will need to know. Okay, so let's look at some different functions and let's decide if it's a polynomial function. If so, we're going to write it in standard form, state its degree, type, and leading coefficient. So in this first scenario, this is not a polynomial because I can't have exponents that are fractions, so this is not a polynomial. In the second one, you see all of my exponents. This would be a degree of 0 right here because it doesn't have a variable with it. So I'm going to put this in standard form, and I'm going to put in standard form, I need to put the largest exponent first and continue decreasing. This is now in standard form. Notice my exponents go from 5 to 4. I don't have a 3 to 2 to 0. And I want to state the degree. The degree of this would be the number of variables in the first term. So the degree of this would be 5. And the leading coefficient would be the coefficient in front of that term, which would be the negative 8. This next function, notice I have an x cubed, and I really wanted that to be in red, and I have an x squared, and then I have a constant. So yes, this would be a polynomial. It already is in standard form, and so this would be degree would be 3, and the leading coefficient then would be the number in front of the cube, which would be a 1. And I'm going to go back and talk about the type in a minute. So let's look at this last example. Two things are wrong with this last example. I can't have negative exponents. I also can't have a variable in the denominator. So this would not be a polynomial. Okay, so going back to number 2, the degree is 5, so this would be called a quintic. Number 3 is a cube. The degree is 3, so it would be a cubic. So now what we're going to do is we're just going to evaluate the function, and what that means is I'm going to give you an x and you're going to evaluate it, which means what point does x equal to? What is the ordered pair that goes with? So what you're used to is direct substitution. So in this case, my function equals -3. I'm going to plug in 2 cubed plus, I'm going to plug in 2 squared minus 12, plug in 2 minus 5. This is going to be equal to -3 times 8. Remember, I'm going to cube first, so this would be -24 plus 4 minus 24 minus 5. So this is -20 minus another 24, so that would be -44 minus another 5, which would give me -49. And if I put this in my calculator and then went to the table, I should then see the ordered pair to -49. Plugging into parentheses is not so important when you have a positive number, but when you have a negative number, it is highly important to plug into a parentheses. And I think you can see the reason why in a minute. I'm going to plug into parentheses. Okay, -2 to the 4th is -2 times -2 times -2 times -2, which is actually going to end up being a positive 16. But here, and I don't need that positive in the beginning, so I'm just going to erase that. Here, I actually have -2 cubed. That actually is going to end up being -8. Remember, -2 times -2 times -2 gives me a -8 times the 2 is a -16. Okay, and then we move to the next term. So -2 squared is -2 times -2, so a positive 2 times 3 would be +6, and then the -7 here. Well, 16 minus 16 is 0, so I get 6 minus 7 would be -1. Now, in the table, I would put in -2, I would find the point -2, -1. So when this function is evaluated at -2, I get -1. So now you're going to learn something called synthetic substitution. We're going to use synthetic substitution to evaluate the polynomial f of x equals 2x to the 4th minus 5x cubed minus 4x plus 8 when x equals -2. So the first step you do is you write the coefficients in order of descending exponents. So I'm going to take the coefficients, and this particular function is already in standard form, so they go exponents 4, 3, 1, 8. So I'm going to write a 2. I'm going to write a -5. I am missing a squared term, so I must leave a space for the square term, the -4, and the positive 8. I'm going to do an upside down division, leaving a line underneath those numbers, and outside I'm going to put the number that I'm being evaluated at. I want to evaluate at -2, so that number comes here. The next step is to bring down the first coefficient. So I'm going to bring this 2 down. And I actually want that in white, so just give me a minute. Bring down the 2. The next step is going to be to multiply the coefficient with the x value. So I'm going to multiply these two. Negative 2 times 2 is negative 4. And I'm going to put that right here. I'm going to add these two together, and I get a negative 9. And now I'm going to do steps 3 again. I'm going to multiply negative 2 times negative 9. It's positive 18. I'm going to put that here. Add those together. And again, I'm going to multiply the negative 2 times 18, which is negative 36, and I'm going to add those two together. And last but not least, I'm going to multiply the negative 2 times negative 40. I'm going to get a positive 80, add those two together, and I get an 88. What this means is evaluating the function at negative 2 gives me 88. Don't forget that after I multiply, I'm putting it into the next one. Sorry, I forgot those two arrows. So this number here at the end becomes my y value, and this number that I evaluated at is my x value. This is synthetic substitution, and we will use it a lot in this coming unit. So I know you're all dying to know if your answers are correct, and so let's move ahead to get the answer to the joke. So I'm trying to find the volume of a cylinder, right? Because this pizza is a circle, but it has height. So the volume of a cylinder is pi r squared h. And they tell me that my r, the radius of this, let me see if I can see that better. Let's see. The radius is z. So this is going to be pi z squared. And then they tell me that the height is a. So I'm going to do pi z squared a. And if I write this out, I get pi z times a. But I can also write pi as this, pi z a. Hoo-hoo! There's the answer to the joke. How do you like it? Have a great day!